Hi, my name is Andrew Nguyen, and here is a demonstration of my semantic sounds project. So, this study aims to look at the relationship between like audio features and the lyrical content using Spotify datasets, in particularly two Spotify datasets, right? And so the objective of this whole project was to kind of like improve on base recommendation system and kind of like tailor the recommendation system to be more into a semantic meanings, like looking at the song lyrics and being able to recommend songs based off of like other songs that have similar meanings. And the reason is because in the music industry, a lot of recommendation system you can filter it by like author or like by the the song name and like kind of like the genre and things like that. But over time, like I feel like users don't have a way to kind of like recommend song based of like the meanings and how much they like the songs, right? And so this study kind of like explore that aspect and using machine learning and also deep learning models as well to kind of build a tailored recommendation system. And so to begin, let's talk about the two data sets. So first of all, the first data set is about 10,000 songs, and it has the song features of Spotify, right? And in these songs features, Spotify already identify what they are and things like that. So I'm not doing that. That's not the purpose. The purpose is to see if I can, from these 10,000 songs, figure out if there's a correlation between the song features that they identify and the song popularity, right? So first I did a lot of EDA or exploratory data analysis, right? And I'm just looking at like the data set and like the kind of like the distribution of the data set, song popularity, like how many artists have the top songs, looking at word cloud, seeing what type of things stood out to me, like the lyrics and things like that, what type of genre is there, just to see kind of like how the data set is. And what I realized is that you can see like here, like a lot of songs like are very skew. It's like very skew towards the left side because the reason why is because um, this is a ranking of popularity and a lot of songs are at zero, so it's just not popular, right? And because of that skewness, right, it causes some complications in the data set that I would have to normalize it, and I kind of have to like get rid of some of the 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 zero factor so that it doesn't affect the modeling as much, right? And so basically what we found is like, there's these numerical features here, right, from Spotify. And I'm just testing to see what type of things correlate with song popularity. Um, After I figured that out, what I did was I used various models and just trying to figure out uh, which model has the best type of result with the song popularity, and then which features itself kind of stood out that correlates most with popularity, and then I integrate these features into the recommendation system, and this is like me building the base recommendation system, right? I did some feature engineering, right? I did hotshot encoding, which is like, oh, I got rid of like just the type of like categorical variables and kind of like give it a numerical number, which kind of like helps the model and like the calculations much better. And what I did essentially is a very simple algorithm. Is typically it's just taking the Euclidean distances. So each song has these associated numerical values, right? And then what I'm just doing is just looking at the kind of like the average numerical differences between each song. So the songs that are closest to the song that you put in, right? A user will input a song. It looks at all the songs that have the closest distance to it, and it will recommend that as the top recommendation. Essentially, it's just that. So we can try it here. Like you can do like some examples. Like I would do like fireworks by Katy Perry. I can misspell. The reason is because I did fuzzy sort of like fuzzy matching, which is like if it slightly misspell the word and stuff, it can still identify which song. So this is just default by 10, right? I guess like here that it wasn't able to, but it's still like, oh, okay, like I kind of put an S here and it's like fireworks. So kind of similar, but yeah, I don't know for here it doesn't recommend. So here, right, I put in fireworks, and then these are the songs that it recommends that are based on popularity features. What correlates closest to this song, like it matches this song vibe or tone as much, right? And so yeah, you can see like a lot of it is just like, oh, a lot of generic pop songs actually, right? Taylor Swift, and then actually recommends another song from Katy Perry, which kind of makes sense. And the same here, right? It's same vibe, same mood, and things like that. Let's try like this is from Justin Bieber. I'm gonna misspell it on purpose just to see like, okay, you can see here like the fuzzy matching is still here, right? Okay. And then now here, yeah, like Heartless, I'm Ready, yep. Stitches by Shawn Mendes, kind of similar pop vibe, right? And it makes sense. Okay, and then that's the first data set. Now I want to talk about the second recommendation system. So this is the base recommendation system. This is the improved one, the one that's based off of semantic meaning. For this one, I'm using a deep learning model called sBert, right? So semantic BERT. And what this model does is actually it analyzes the lyrics of the song and it's able to understand the semantic or human meanings behind the lyrics. And so I have like essentially what I do is this data set has all the lyrics and I'm combining it with the first data set and then matching it on like the song artist and song title, right? And then now I'm running sBert on the lyrics. And so now I'm able to get these thing called the sBert embedding. So once I have the trained like deep learning model embedding, what I'm doing is I'm just essentially adding that into the base recommendation system and seeing how that affects the recommendation system. So it's kind of cool. So you can see these are the clusters, like the different various clusters methodology I try, right? And just see like which one can kind of like visualize the embedding the best. Um, and here, let me see, not right here. Oh, right here, yeah. So you can kind of see, yeah, this is like really good embedding visualization. So this is the after combining it with the deep learning model with the base recommendation system, this is like a visual representation of what's going on in the recommendation system, essentially, right? So they saying these songs are similar in meaning. The closer they are, the more similar they are in meanings. You can see like you have these small pockets of island, right? And so now let's try the recommender here. So do the same songs, right? Fireworks, Katy Perry, and then I'm gonna do this. Okay, Katy Perry, yeah. So now you can see the songs that it recommends here because the lyrics of fireworks is more like about like explosiveness or being like burn and like fire things exploding. So it's kind of cool, it's kind of cool to see that, oh, a lot of the songs here they recommends like burn, firefly, like something that is like passion or something that burns. So it feels like it kind of understand the meaning, right? And we can try like different things, right? uh, Here as well. And here you can see that this song is like romantic, like it's about a lost, a love, someone you love, or uh, you know, so it feels like here it also recommends you a lot of songs that sound that's very similar to that, right? Um, and then here's the most kind of like the most best evidence is this song. This is by Lady Gaga, and this song is highly religious in meaning. Judas is a very highly religious song, so you can see that here in the actual like semantic meaning recommendation system, right? The improved one, you can see it's recommending very religious song. The Edge of Heaven, When You Were Young, Original Sin, Stronger, Sorry, Devil Inside. Like these are all like very highly religious motif, right? But here you can see with the base recommender, it's nothing like that. So it's really cool. You can see that you can actually see it's working because here you can see that, oh, this is more like, it's still more pop song. It's still more like generic pop song that kind of captured the mood or the vibe of the tone of the song, but it doesn't capture the meanings of the song, right? And so there, yeah. This is my improve this project to improve the base recommendation system using semantic BERT. I hope you enjoy that. Thank you.